Hi teacher, my name is Koh Ming Ming and my group member is Xu Jinxiong and Teo Yang Xiang and we are from group Lengchais. This is our case study presentation and we're gonna discuss about the risk assessment using hierarchy analysis. Okay, let we move to the next part. Okay, let me show you about our contents. Today I'm gonna take the part of introduction. I will introduce about the title and the importance of industry safety. And the part below will be presented by my friend. Okay, let me move to the next slide. Okay, this is about our introduction. Okay, industry accidents continue to pose significant risk to workers, organizations, and the wider community. In Malaysia, numerous incidents involving factories and industrial sites highlight the importance of adopting systemic risk assessment strategy. One of the most effective tools available is the HIRAC, Hazard Identification, Risk Assessment, and Risk Control methodology. And that's all about our introduction. Let me move to the importance part. Okay, this is the importance of industry safety in engineering practice. We got two importance here. The first importance is protection of human life and health. And the most critical goals of industrial safety is safeguarding workers from injuries, illness, and fatalities. And engineers are ethically bound to the priorities workers' welfare as reflected in professional code of conduct. And the second importance is the legal and regulatory compliance. In Malaysia, law such as the Occupational Safety and Health Act, also called OSA, in 1994, and the Factories and Machinery Act 1967, mandate safe work practices. And non-compliance can result in penalties, lawsuit, and even shutdown of operation. Okay, the third importance is improve productivity and efficiency. How how industrial safety in engineering practice can improve productivity and efficiency. A safe workplace will reduce accident, machine downtime, and compensation costs. Workers perform better when they feel secure, leading to higher output and efficiency. And the last importance is cost reduction. By preventing accident, save money by avoiding medical expense, legal claims, repair costs, and insurance premium. In investing in safety system is always cheaper than dealing with accident. Okay, my friend will continue our presentation. Thank you, teacher.
On 24 February 2025 at around 2 p.m., a rubber processing factory in Tangkat, Johor was the site of catastrophic explosion. According to media reports, maintenance activities were being carried out on 5 machines that were still in operation. During this process, one of the machines suddenly exploded, resulting in a devastating impact. The casualty includes 2 local Malaysian workers were killed instantly, 7 workers sustained serious injuries. The injured included migrant workers from Bangladesh, Nepal, and Myanmar. The immediate response are the injured were transported to nearby hospital for urgent treatment. Post-mortem examination were conducted on the deceased workers. The case was classified as a sudden death and is under investigation by the authorities.
Finish the incident introduction. We'll start at the start with the hierarchy analysis. First is the maintenance work. Hazard and cost is during operating machinery during maintenance. It can lead to severe injury or death due to entanglement or crushing by moving machinery. Basic PPE is provided, but it is quite insufficient and no lockout or tagout enforcement is added. Likelihood of it happening is 4, the severity is 4, letting the risk turning into 16, making it a high risk level. Additional controls to handle the situation is through engineering control, which is to install machine interlock, physical guards, and automatic shut-off system. For work practice control, we can add strict lockout, tag out, lotto enforcement, or written SOPs. For PPEs, we can prepare safety gloves, helmet, face shield, and steel toe boots. The person in charge should be the maintenance supervisor, and it should be done in 2 months. For machine operation, it can lead to explosion of machinery, can cause fatal injuries, burns, structural damage, or multiple casualties. Existing control for it is it has standard machine maintenance routines, but it is inadequate for explosion prevention. Likelihood of this happening is 3, the severity is 5, making the risk 15, and the risk level high. Through engineering control, we can upgrade it to explosion-resistant machinery or install pressure relief valves. For work practice control, we can conduct hazard analysis before maintenance and enforce work stop authority. For the PPE, we can prepare flame-resistant clothing, goggles, and ear protection. The person in charge should be the factory manager, and it should be done in 5 months. Next is the electrical work. The hazard of it is electrical hazard, and it can lead to electrocution, burns, and potential fire breakout. Existing control for it is circuit breakers and fuels that are not linked to motor system. Likelihood of this happening is 3, the severity is 4, and the risk is making the risk 12, letting it into a high risk, medium risk level. Engineering control for it is through electrical isolation device and residual current devices RCDs. The work practice control, we can go for electrical lockout procedures and only let certified electricians to touch the machines. For PPE, we can have insulated gloves, dielectric boots, and upgraded face shield. The person in charge should be the electrical engineer, and it should be done in 2 months. Last is the maintenance work. We can go for hazards for like lack of lockout and tagout. It can lead to uncontrolled release of energy, making letting serious injury or death. Existing control of it is a general safety awareness, but no formal lotto system. Likelihood of it happening is 4, the severity is 4, making the risk 16, turning it into a high risk level. Engineering control, we can install lockable isolators and tags on all machinery. For the work practice control, we can formalize local SOP, train staff, and periodic refresher training. For the PPE, we can add safety helmets, gloves, and reflective vests. The person in charge should be a safety officer, and it should be done in 1 month.
Finding and recommendation. Findings. First, maintenance was conducted while machines were operational, violating standard safety procedure. No evidence of a lockout takeout system in place. Workers, especially migrants, may not have received adequate training. Engineering safeguards such as interlock or explosion-resistant design were either absent or insufficient. Emergency preparedness measures were limited. For the recommendation, first, enforce LOTO. Factories must ensure machines are completely de-energized before maintenance. Second, enhance training. Implement continuous multilingual safety training for all workers. Third, upgrade equipment. Replace outdated machine with safer explosion-resistant model. Safety audits. Conduct periodic audits. Emergency system install fire suppression and alarms. Last, strengthen safety culture. Conclusion, the Tangkat rubber factory explosion is a tragic reminder of the consequence of neglecting safety protocol in industrial environment. 2 lives were lost and several workers were injured due to the preventable hazard. The hierarchy framework provides a systematic method to identify, assess, and control this hazard effectively. Key lessons include the importance of adhering to lockout takeout procedure, providing multilingual training for diverse workforces, and upgrading machinery with adequate engineering safeguard. Organization must embrace a proactive safety culture not only to comply with OSHA 1994 but also to protect human life and ensure sustainable operation.